Hi student, welcome to my video live center. Today we'll solve MCQs on line and plane in mathematics part first for GE main and Maharashtra state CET. And first MCQ is find the Cartesian equations of the line which passes through the point -2, 4, -5 and is parallel to the line x plus 3 upon 3 is equals to 4 minus y upon 5 is equals to z plus 8 upon 6. In this multiple choice questions, we find the equations of the line, that is the Cartesian equations of the line. And here options are given. Option A, x plus 2 upon 3 is equals to y minus 4 upon minus 5 is equals to z minus 5 upon 6. Option B, x minus 2 upon 3 is equals to y minus 4 upon minus 5 is equals to z plus 5 upon 6. Option C, x plus 2 upon 3 is equals to y minus 4 upon minus 5 is equals to z plus 5 upon 6. Option D, x plus 2 upon 3 is equals to y minus 4 upon minus 5 is equals to z minus 5 upon 6. So here we find the Cartesian equations of the line, and the required line is passing through the point -2, 4, -5. -2, 4, -5. And required line is parallel to the given line whose Cartesian equation is given. And now that the two lines are parallel, then their DRS are equal. Therefore, here we use the key points in line. That key points is, now that the equations of the line passing through the point x1 minus z1 having DRS ABC is x minus x1 by a, y minus y1 upon b is equals to z minus z1 upon c. So here x1 y1 z1 is given, that is x1 is -2, y1 is here 4 and z1 is -5. Our aim is to find out ABC, that is the DRS of the required line. And here the required line is parallel to the given line whose Cartesian equation is given. Therefore, here the DRS of the required line and given line are equal. So we find here ABC from the given line. So given equations of the line can be written as the given equations of line is x plus 3 upon 3 is equals to 4 minus y upon 5 is equals to z plus 8 upon 6. This we write these equations in the form of x minus x1 upon a is equals to y minus y1 upon b is equals to z minus z1 upon c. So x plus 3 upon 3 as it is, this can be written as here multiply numerator and denominator by negative signs. So this is y minus 4. Here positive into negative minus 5 is equals to z plus 8 upon 6. Therefore, here the DRS of the given lines are 3 minus 5, 6. And the required line is parallel to this line. Therefore, the DRS are equal. So again, the DRS of the required line are 3 minus 5, 6. And the required line passing through the point -2, 4, -5. Therefore, the equations of the required line in Cartesian form is x, negative, negative, positive, x plus 2 upon 3, y minus 4 upon minus 5, z plus 5 upon 6. So z plus 5 upon 6. And this is the required equations of the line in Cartesian form. Therefore, here B is the correct option. That is x minus 2 upon 3 is equals to y minus 4 upon minus 5 is equals to z plus 5 upon 6. This is the solutions of the first multiple choice questions using shortcuts method. Next, if line x minus 1 upon minus 3 is equals to y minus 2 upon 2k is equals to z minus 3 upon 2 and x minus 1 upon 3k is equals to y minus 5 upon 1 is equals to z minus 6 upon minus 5 are mutually perpendicular, then k is equals to option A minus 10 by 7, option B minus 7 by 10, option C minus 10, option D minus 7. Again, the two equations of the lines are given in Cartesian form. And here we find the value of k if the given lines are mutually perpendicular. So from the given equations of the line, we find the DRS of the first line and DRS of the second line. We know that the DRS of the first line is denoted by A1, B1, C1 and DRS of the second line is denoted by say A2, B2, C2 and two lines are mutually perpendicular, then the condition is A1, A2 plus B1, B2 plus C1, C2 is equals to 0. We use this key point and find out the values of k. So DRS of the first line minus 3 2k 2. DRS of the second line 3k 1 minus 5. So we write here DRS of the first line, that is minus 3 2k 2. Minus 3 is denoted by A1 2k, here B1 to C1. DRS of the second line R. Here DRS of the second line 3k 1 minus 5. So we write here DRS of the second line 3k 1 minus 5, which is denoted by A2 B2 C2. And here the given lines are mutually perpendicular. Then the condition is here A1 A2 plus B1 B2 plus C1 C2, which is equals to 0. Then we find here A1 A2 plus B1 B2 plus C1 C2. Here A1 A2 3k into minus 3 minus 9k plus 2k minus 10. Here minus 9k plus 2k minus 10 equals to 0. Minus 9k plus 2k, that is minus 7k, which is equals to 10. Therefore k is equals to minus 10 by 7. This is the required value of k. Therefore here a is the correct option, that is minus 10 by 7. Next, multiple choice questions. This is again one very most important multiple choice questions for JEE main or JEE advanced. Dear student, if you like my video, please subscribe my channel and press on bell icon. Find the equations of the line passing through the origin. Here line passing through the origin, which intersect the line x minus 3 upon 2 is equals to y minus 3 upon 1 is equals to z minus 0 upon 1 at angle pi by 3. Then option A, x by 1, which is equals to y by 2 is equals to z minus 1. Option B, x minus 1 is equals to y by 1 is equals to z minus 2. Option C, x by 1 is equals to y by 3 is equals to z by 2. Option D, both A and B. So in this problem, line passing through the origin. Therefore, x1, y1, z1 is given. x1 is equals to 0, y1 is equals to 0, z1 is equals to 0. Therefore, the required equations of the line is of the type x upon a is equals to y upon b is equals to z upon c. Therefore, our aim is to find out ABC. ABC, that is the DRS, direction ratios of the required line. And in this problem, it is given that the required line intersect the given line whose equation in Cartesian form is given at angle pi by 3. That is the required line intersect the given line at angle pi by 3. So here we find A, B, C by using one result or one key point, that is cos theta is equals to mod A1 A2 plus B1 B2 plus C1 C2 upon under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square, where A1 A1 A2, where A1 B1 C1 DRS of the first line, A2 B2 C2 DRS of the second line, and theta is the angle between these two lines. So we use this key point and find out the equations of the line. So first we write here the DRS of the given line, that is 2 1 1. This is A1 B1 C1. 2 1 1. This is the DRS of the given line. So we write here the DRS of the given lines are here 2 1 1, which is denoted by A2 B2 C2 or A1 B1 C1. Then we find here the DRS of the required line, that is A1 B1 C1. So we understand this problem with the help of the figure. Suppose this is the given line whose equation in Cartesian form is given x minus 3 by 2 is equals to y minus 3 by 1 is equals to z minus 0 by 1. And here DRS of these lines are 2 1 1. So in this figure, this is a given line having DRS 2 1 1. And the required line passing through the origin and intersect the given line at angle pi by 3. So this is first line, that is OA, and this is second line, that is OB. Both these line makes an angle of pi by 3 with the given line. That is here we find the, or here we get the two equations of the lines. That is here we get the two equations of the required line. Because from origin here two line passes, that is line OA and OB makes an angle pi by 3 with the given line. So here first we find here the point of intersections of the line OA and the given line. Means here we find the coordinate of the point A. First we find here the coordinate of the point A. So given equations of the line, given equations of line x minus 3 upon 2 is equals to y minus 3 upon 1 is equals to z minus 0 upon 1. So here we find point lie on this line. That is we find here x, y, z. So first we find here the x, y, z. X minus 3 by 2, y minus 3 by 1 is equals to z by 1. This is the given equations of the line, which is equals to say constant lambda. And from this we find the value of x, y, z. X is equals to here 2 lambda plus 3. We write here 2 lambda plus 3. Y is equals to lambda plus 3. And z is equals to 1 into lambda, that is lambda. Then we find here DRS of OA. Here we find DRS of OA. That is A1, B1, C1, DRS of OA. When now that the coordinate of O is 0, 0, coordinate of A, we find here the coordinate of A, 2 lambda plus 3, lambda plus 3, lambda. Then by using here the key points, and we find here the DRS of OA, that is x2 minus x1 comma y2 minus y1 comma z2 minus z1. We use this and find out here DRS 2 lambda plus 3 minus 0, 2 lambda plus 3, lambda plus 3 minus 0, lambda plus 3, lambda minus 0, that is lambda, and this is the DRS of the required line. And here we find the value of lambda. And if I get lambda, then putting the value of lambda here, we get the DRS of the required line. That is A1, B1, C1. So for this, for finding out the value of lambda, we use here the formula cos theta is equals to mod A1 A2 plus B1 B2 plus C1 C2 upon under root A1 square plus B1 square plus C1 square into under root A2 square plus B2 square plus C2 square. So we use this here cos theta, but theta is given, that is pi by 3. And we know that cos pi by 3 cos 60, and value of cos 60 is 1 by 2, which is equals to mod A1 A2 here 2 lambda plus 3 into 2 plus b1 b2 lambda plus 3 into 1 plus c1 c2, that is lambda into 1 upon under root a1 square, that is 2 lambda plus 3 whole square plus lambda plus 3 whole square plus here lambda square into under root a2 square plus b2 square plus c2 square. A2 b2 c2 are 2 1 1, so 2 square, that is 4 plus 1 square 1 plus 1. Therefore, here 1 by 2 is equals to, if we solve the numerator, after solving numerator, we get 6 lambda plus 9 upon under root. Here we solve the square in the first under root, so we get 6 lambda square plus 18 lambda plus 18. Into under root here 4 plus 1, that is under root 6. Then here from this under root 6 take common, under root 6 into under root 6, that is 6. From numerator here 3 take common, so 3 by 6. Right here 1 by 2 is equals to 3 by 6 mod 2 lambda plus 3 upon under root lambda square plus 3 lambda plus lambda. Then here 2 into 3 6, 6 6 get cancelled, so we get here 1 into this under root, we get under root lambda square plus 3 lambda plus 3 after squaring both sides, so we get square and root cancel, lambda square plus 3 lambda plus 3, which is equals to 2 lambda plus 3 whole square, and expand this with the help of the formula a plus b whole square, a square plus twice ab plus b square. Similarly 4 lambda square, 2 into 3 6, 6 into 2 12 lambda plus here 9. Then 4 lambda square minus lambda square 3 lambda square, 12 minus 3 lambda, so we get here plus 9 lambda, 9 minus 3 here 6, which is equals to 0. And here divided both sides by 3, so we get lambda square plus 3 lambda plus 2 equals to 0. Here lambda square plus 3 lambda plus 2 is equals to 0. And this is the quadratic equation in lambda. It has two roots. We find the roots of the quadratic equation. And roots of the quadratic equations are lambda is equals to minus 1 or lambda is equals to minus 2. So putting the value of lambda in DRS of line OA, putting the value of lambda which is equals to minus 1 or lambda is equals to minus 2 in DRS of the line OA, that is here. We put here lambda is equals to minus 1 and lambda is equals to minus 2. So we get here the DRS of the line OA. If we put lambda is equals to minus 1, then the DRS of the line OA are 1, 2, minus 1. If we put lambda is equals to minus 2, then we get DRS of the second line, that is the line OB, drawing figure. So DRS of OB is equals to minus 1, 1, minus 2. Therefore, here the correct options are both A and B, because here DRS 1, 2, minus 1, and here DRS minus 1, 1, minus 2. See here 1, 2, minus 1, minus 1, 1, minus 2. So here both, that is option A and option B, are correct. Therefore, here D is the correct option, because here both, this is the equations of the line OA and this is the equations of the line OB. Therefore, both A and B are correct options. So in this way, we solve the MCQ on the unit line and plane. Again, we request you, if you like my video, please subscribe my channel and press on bell icon. Thank you.